The Chapter 3 test is on Wednesday, so today we'll review. We'll start off with rounding. Now, rounding is still a little bit of an issue for some people, but it's not that difficult if you follow some simple rules. If you're rounding to the nearest tenth, you should first find the place that you're rounding to. And in this case, I'm going to be underlining the place value, which is the tenths, for each of these three numbers. You're then going to look to the right. When you look to the right, you see 5 or greater, you round up. This is approximately equal to 2 5/10. On to the next problem. Again, if I'm rounding to the nearest tenth, which is the sevenths, we're going to look to the right. Less than 5 says to round down, so this is approximately equal to 32 7/10. And in the last one, this 8 tells me I should go ahead and round up, so this is approximately equal to 431 1/10. Another place value that we spent some time rounding to was the whole numbers, and sometimes I'll refer to that as rounding to the nearest integer, because integers are whole numbers. So if I'm rounding to the nearest whole number, I'm going to once again underline the place that I'm looking for. Now, if you notice in the top row as well as in the bottom that you round to the place that's asked for and don't add any digits beyond there. So now I'm looking to the right once again. That number tells me to round down. This number is closer to 7 than it is to 8. On my next one, again, rounding, and I look to the right. This is approximately equal to 26. On to the next number. It tells me to round. I'm going to round to the nearest place, and this time it's the 7. I'm going to round to the nearest place, and it's going to give me approximately equal to 249. And there you have your rounding. Rounding to the nearest tenth, rounding to the nearest whole number. We can round to any place value, but these are the two that we focused on most in class. We moved on from there to talk about estimation of sums and differences. We can use front end with adjust, we can use clustering, and we can use rounding. You can choose the method for all of these, and again, it's an estimation or approximation. It's not the exact answer. I'm going to use rounding for the first one, and I'll get 8 plus 6 plus 6, which is approximately equal to 20. My second problem, I'm thinking about clustering, and I see that they're all around 11, and there are 3 different terms here, so this is approximately equal to 33. You may have decided to round. We'll compare answers if you chose a different method. We can also estimate our differences by subtracting. This will give me 24, I'm rounding, minus 11, approximately equal to 13. Now in the last one, I could cluster once again because I see they're all close to 20, and I see there are 4 of them, and I recognize that to be approximately 80. Now what if you chose to round, for example? You would have 20 plus 20 plus 20 plus 19. So you would get approximately 79. And you see our answers are very close to each other. And that's an approximation or an estimation. From there, we moved on to sums and differences. I'm sorry, no, we did sums and differences. We moved on to the products and the quotients, sorry. We're going to round to the nearest whole number in this case, and this is going to give me 8 times 4. So that answer is about 32. The second one is another product. We'll round, and we'll say this one is about 36. When we got to quotients, this was something slightly different, and yet I thought you did a nice job with these. You round your divisor, okay? So you're going to round the divisor, which gives me 7. And then I'm going to find a number that's compatible. So I'm thinking of my multiples of 7 or my 7 times table, and I stop when I see something close to it, either slightly above or slightly below, and that gives me approximately 7. A second problem just like this, we'll round our divisor. We'll think of our numbers that are compatible, and I see that I can have approximately 7 for this one. Again, 63, 9 times 7 is 63, which is close to the 64. From there, we took a look at mean, median, mode, and range. I asked you to find the median. Well, remember when we're finding the median, we'd like to line up these numbers in order from least to greatest. I tend to do that with all of my measures of central tendency, but this is one in particular that really needs to be done in order. We've got two middle numbers, so we'll add them and divide by 2. 28 divided by 2, 24, I'm sorry, 24 divided by 2, my median is 12. Range says take your highest number, subtract your lowest number, and you'll find your range. When I'm looking for mode, I look at numbers that appear most often in a set of data. As I'm looking across, I see that there are 3 5s, which is the most of any number there. So my mode is 5. The last thing I'm looking at on this slide is my mean. You take your numbers and you add them all up. Should I order them from least to greatest? I could. Not 100% necessary. Some people like to, and generally I would. But in this problem, I'm going to line them all up in order that I got them, add them, and divide by 5. We'll compare answers in our session. On to formulas. We talked about everyday common formulas like the area of a parallelogram. If I know the base and I know the height, I simply multiply and I put my units, unit analysis. This is feet squared. There were no decimals there, so that was nice and easy. Distance, another formula we've used quite often, distance equals rate times time. Well, if I know that my rate is 35 miles per hour and I'll be traveling for 2.5 miles, I'll take these two numbers and multiply, and I'll see what I get. And I get 87 5/10, and that's 87 5/10 miles because I'm looking at distance. And those were just two of the types of formulas that we had worked on. The very last topic, which is the one we just finished up, was dealing with decimals in solving equations. Looking at that one inverse operation. The key to this is if I'm adding, I want to line up my decimals. I want to watch my operation signs, and I want to be sure that I have lined up my place values as well as my decimals. Since this is an addition and the signs are unlike, you see I'm going to need to subtract. And I see that I keep the sign of the greater absolute value, and I get a negative 22 1/10. In a subtraction, because that's the inverse of addition, I once again will line up my places. And I'll see that I get an opportunity here to regroup or rename a little bit. And I place my decimal, and I see I have 35 54 hundredths. Let's subtract again. Now there's no decimal in this one, which means that the decimal is at the end of the number. And it's important that I put that because I need to be able to regroup here and subtract that 4/10. And I'll see that I have x is equal to 12 6/10. Last row. This is multiplication, so we'll divide. We're taking 7 542 thousandths divided by 3 hundredths. We want to divide by a whole number, so we're moving that decimal over 2 places. That's multiplying by 100. So now we're dividing by 3. Let's subtract and bring down our next digit. Well, 3 will go into 15 5 times without a remainder. So I'll bring down my next digit. It will go into 4 once. We'll subtract and bring down again. And we'll see that it terminates because my remainder is 0. And on to the next problem. Again, I'm dealing with a negative 4/10, and I'm dividing that into 7 632 thousandths. decimal moves one place over and into the quotient. My answer is going to be a negative. So I have a negative. It goes in once. Subtract, and I did that again. Let me subtract and bring down. My next digit is a 6. Well, that will go in 9 whole times without a remainder. Bring down my next digit. Well, 4 is not divisible by 3. That's a 0. So I'll bring down my next digit, and I get 8 with a remainder of 0. So my answer is a negative 19 8/100ths. Following along to one last problem for today. That one last problem involves multiplication, because the inverse of division is multiplication. We'll take that 3 72/100ths and multiply by 6/10ths, and let's see what it gives us. We've got that 12, that's 42, and 1 is 43, and 18 plus 4 is 22. Let's count up our decimal places. We see we need 3 in our product, so x is equal to 2 and 232 thousandths. There's our review of equations with decimals, and that is the end of our review for Chapter 3.